value of aggregate output is determined in the goods and services market, isn't it? And we looked at 3 different approaches to find equilibrium in the goods and services market. What were those approaches that we discussed last time? Anybody remember what's it? Go ahead.
Algebraically.
Algebraically, okay. That's one approach. What else? Megan? You can plot it. So look at the graph and what was the third one? Savings and investment approach. You can do that. We used numerical, approach, right? We constructed a table, and that also allows you to find equilibrium in the goods and services market. Let me redo all those things quickly today, just to refresh your memory, and then we'll do multiplier. That's the only thing we have to do from chapter 8. That's remaining from chapter 8. Okay, so we'll talk about that. Let me quickly go over all those approaches using different numbers. Okay, it will be a good exercise for you guys. So what I want you to do is work along with me. I'm going to work on the board. You work on your own, right? You know all the approaches. So let's do that. Let's say we have. Let me give you a new consumption function, an investment function. Okay, and then we are going to find the value of real GDP. Right? So let's suppose consumption is given by 200 plus 0.75 y. That's your consumption function. And let's suppose investment, which is an exogenous variable, as I mentioned before, it's predetermined, we know the value. Let's suppose it is $200. So given this information, we need to find the value of GDP, real GDP, y. Okay. So you can plot it, you can use a numerical approach, construct the table and get the value of GDP, or you can do it algebraically, right? So let's construct that table first, okay? And that will allow you to do a lot of other things with it. So we got y and c and I. So let me give you different values of y. 0, 100, or we can go with 200. That might work. Let me switch to a new slide. Y, C, and I. 0, 200, 400. And so basically y changing by 200. So you have to tell me what are the corresponding levels of consumption given the consumption function that I provided you in the previous slide. So consumption function is 200 plus 0.751. So marginal propensity to consume is 0.75. So let's get that. So plug in 0, so you get 200. And then you plug 200 into the function and get 350 over there. $200, $350, $500, $650, $650, $700. That's 800. investment is 200 per hour. So let's extend it to 1600. So the 1250 plus 150, 1400. All right, got all those numbers. Do they look all right so far? So what's the next thing I have to do here to find equilibrium in the goods market?
Add C and I together.
Add C and I. What does that give you? What is C plus I? Planned aggregate expenditure, right? So let's add those. 400, 550, we get 700, we get 850, we get 1000, 1150, 1300, 1350, and 1600. Right. So what is the equilibrium value of GDP in this economy? 1600 because
Y and C plus I are the same.
Y and C plus I are the same thing. Aggregate output is same as the planned aggregate expenditure. So that's correct. So we got this and this equal. So the equilibrium value of GDP is 1600 in this economy. Another way you can calculate GDP here is by looking at what? What else can we do with this table that gives us the equilibrium value of output?
The change in inventory?
Change in inventory. You can calculate change in inventory. And how do we know
When it's 0?
when it's 0? When change in inventory is 0. That's correct, right? So how do I calculate change in inventory here?
Y minus C plus I.
Y minus C plus I, right? So that's another thing we can do. So change in inventory is your Y minus. So this would be Y minus C plus I. So you can subtract C plus I from Y to minus 400. And then you get what? 200 minus 550, you get negative. Is it 350?
Yeah.
So by how much is changing? Negative. So 300, 250, 200, 150, negative 150, negative 100, negative 50, and 0. If you have more, then it will become positive after that. So when change in inventory equals to 0, that will also give you the equilibrium value of output. Corresponding to that, you can read the GDP, right? Y. What else can we do with this table to find equilibrium? Is there any other approach that we can take here?
Savings.
Savings. So what is that equilibrium condition? Do you remember the equilibrium condition using?
Is it Y minus C?
Y minus C is saving. That's correct. So you get saving, but how do we? Go ahead.
S equals I.
S equals to I. That's correct. Savings equals to investment will give you equilibrium as well. We already have I, investment given, right? The only thing we have to do is calculate savings. So savings would be Y minus C. So let's do that. So Y minus C is savings. We start at negative 200 and then negative 150 and so on. That's your 200. So when savings equals to investment, that also gives you equilibrium in the goods market. So that you can see the equality takes place when savings equals to 200 and investment equals to 200. And that corresponds to the value of y, which is 1600. Okay. Is that fine with everybody? This is what we did last time, So I'm just trying to refresh your memory. Okay. Now next you can plot it. Use the graphical approach, right? So let's do that. One way you can plot it, just plot all the numbers you have, right? You can plot C plus I and 45-degree line, and intersection will tell you the GDP, isn't it? Or you can just look at consumption function, investment function, you can plot those things, and that will also give you the answer. So let's go and look at. So graphically, you are looking at Y over here, and planned aggregate expenditure, which is C and I. So let's plot investment first. We know investment starts at $200 and it is exogenous, independent of the state of the economy. That's our assumption so far, right? So it will be like this. So that's your investment function if you plot it. And next we have to plot C plus I line, right? Planned aggregate expenditure line. So where does C plus I line start?
200. Oh,
400. That's correct, because consumption, autonomous consumption is 200, right? And investment is 200. So starts at 400, and then what is the slope of aggregate expenditure line? 0.75. Slope of planned aggregate expenditure is same as the slope of consumption function, right? So I can draw a consumption function starting from here. It goes like this, right? I'm just skipping that part. Or you can just draw that. So that's your, let's say, consumption function, which is 200 plus 0.751. And then I'm going to add those two. So if I add, it will look similar to your consumption function, but so this is your C plus I line. It has the same slope. It starts at 400. Okay. What's the next step to find equilibrium output? What do I do next? Anybody? Go ahead.
Do you plot a savings line? Is it?
We'll look at savings and investment too in a separate.
Isn't it like a straight line up, and then wherever it meets, that's equilibrium?
So for the time being, we are just looking at equality between aggregate output Y and planned aggregate expenditure C plus I line, right? So how do I know that? Where the equality will take place?
You have to draw the 45 line.
I have to draw the 45-degree line, isn't it? 45-degree line, what does it do?
Where it intersects is really with the equilibrium.
That's correct. So where 45-degree line intersects planned aggregate expenditure line, it gives you equilibrium in the goods market. But why 45-degree line? What is the purpose of drawing the 45-degree line?
Because it's equal on both sides.
Because it gives you equal values, right? Any point you take on 45-degree line, it gives you equal values of aggregate expenditure and GDP, isn't it? So we know equilibrium is basically equality between planned aggregate expenditure and aggregate output. So it must lie on 45-degree line. Okay. So let me just draw that for you. So the 45-degree line is like this. So now we have the intersection taking place here, and that gives you the equilibrium value of GDP and also planned aggregate expenditure. They are equal at that intersection, right? So what is this value? Now we know the value, right? Where does the intersection take place?
Was it like 1,500 or 1,600 or something?
1,600, right? So $1,600. So that's your graphical approach, where you're looking at equality between aggregate output and planned aggregate expenditure, giving you the equilibrium in the goods market. Is that fine with everybody so far? So, I'm still trying to refresh your memory, everything we did last time, right? Did we plot savings and investment approach last time? Did we have the graph for that? No? Let's do that today. So, let me go to the next one. So now you want to find equilibrium in the goods market using savings and investment approach, right? And we are going to draw them. We already know the value from the table, right? So how do you draw them? Let's look at it. So this is your y. And that's your 0. Let's plot savings function. You know consumption function. You can draw savings. You can write savings function, isn't it? It's the mirror image of consumption function. So our consumption function is 200 plus 0.75y. So what is the corresponding savings function? Can somebody tell me? Go ahead.
Minus 200 plus 0.15y.
0.15y.
No?
You're close. I think.
Oh, 25.
That's correct.
Sorry.
Yeah. No, you're right. I was just.
Numbers.
So minus 200 plus 0.25y. What is minus 200 here in savings function? What does it tell us?
Is that your planned investment?
Is that your planned investment? No.
When your income is 0, you're spending $200, so your savings go down.
That's correct. When your income, hypothetically speaking, suppose your income is 0, we know your consumption is positive, $200 at that level, right? That $200, you are drawing it from your past savings, right? And therefore your savings goes down by $200 at hypothetical income of 0. So that's your aggregate 200. And what is 0.25? What does it mean here? Go ahead.
That's how much of your income you're saving.
How much of your income you are saving? You're close, but you have to give me the exact interpretation of 0.25. Intuitively, I think you understand it, but you have to give me exact meaning of what it means here. What is 0.25? What do we call it? What's the that number? What does that number represent?
The slope?
The slope of? It is slope. You're right, but slope of what? Savings function, consumption function,
Savings function.
savings function. And what is the economic interpretation of this slope? Slope of savings function is also known as MPS, marginal propensity to save. That's correct, isn't it? So 0.25 is your MPS, marginal propensity to save. And can somebody define it for me? Marginal propensity to save. Who has the definition of MPS? Megan? Don't remember? Anybody who remembers MPS? If your income goes up by, let's say, $1, how much of that $1, extra dollar that you have earned, goes towards savings? 25 cents. That's your interpretation of MPS, right? All right. So now we have savings function. We just have to plot it, right? So I know when income is 0, plug in 0, you get savings equals to negative 200. So that's one point you got, one coordinate. And as income increases, savings starts rising at the rate of 0.25, isn't it? For every $100 increase in income, saving will rise by $25. That's what he's saying. So it has a positive slope of 0.25. So the question I have for you now is, at what income level does the saving become 0? At what income level does the saving become 0?
800.
How much?
800.
800? How do you know that?
Like it's from the.
So when S equals 0.
When S equals 0, you solve for it, right? So you plug in 0 over here, right? And then solve for y, and that gives you the value. So if it's 0, it becomes 200. So y equals to 200 divided by 0.25, which gives you $800. Okay? So that's correct. So let's say $800 is here. So I got another point here. When income is $800, savings is 0, right? So you need just, it's a straight line equation, you need just 2 points to draw the straight line. So my saving function will look like this. That's your savings function. Has a slope of 0.25. Okay, it should be a little flatter, but the way I have drawn, trust its slope is 0.25. Okay. And what is the next thing that I have to draw here? Investment, right? So investment we know is a straight line, horizontal line, starting at $200. So let's say 200 is here, and that's your investment line. So intersection between savings and investment will give you equilibrium in the goods market. So that intersection takes place here, and we already know the value, which is 1600. That's correct. So that's your graphical approach to finding equilibrium in the goods market using savings and investment. Okay, is that fine with everybody?
Can you just repeat how you, is your investment, that's the number, that's the 200 in the consumption function?
Investment is,
And the consumption function is the investment, is that I know it's 200, but is that the same number?
you want me to go back to the slide, previous slide?
Yeah.
Okay, let's do that. So, click on this. So let's look at investment. So just draw investment, right? Investment we know is $200, and it remains $200 no matter what the income level is.
Well, where do we get that $200? That's what
I'm giving you that.
Okay.
That's why we call it exogenous variable. It's determined outside of the system. That's an assumption, right? For the time being. Okay, we're assuming that the value of investment is predetermined. Okay? That was your question?
Yeah.
All right. Any other questions? So let's come back to this one. So that's your saving and investment approach. Now, next, let's look at algebraic approach quickly. Okay? So, let's start with y equals to c plus r. That's your equilibrium condition, right? So let's just substitute the values of c and I and solve for y. That's the only unknown we have, right? So y equals to 200 plus 0.75y plus investment, which equals to 200. So this is your consumption and this is your investment. Okay, so I just substituted the values of C and R in the equilibrium condition. So as you can see from this expression over here, the only value that is not known is y. Y is the only unknown here, right? So we can solve for it. So let's do that. So I, subtract 0.75y from both sides. So I get 1y minus 0.75y equals to 200 plus 200, 400. And 1y minus 0.75y gives you 0.25y, which is equal to 400. Divide both sides by 0.25y to solve for y. So you get y equals to 400 over 0.25. That gives you 1600. That's what we have been finding all along, isn't it? So that also gives you the same answer. So that's one algebraic approach. The other one is you can use savings and investment. Isn't it? Savings equals to investment will also give you the same answer. Is that fine with everybody so far? Before I move on to savings and investment approach. This is aggregate output equals to plan aggregate expenditure. It's algebraic approach, but you are using one equilibrium condition. And savings equals to investment is also a derivative of this. We derive from this. Let me go back to why savings equals to investment comes from this. You will see that. I think we did it last time, but just for your know. So we know income is always equal to consumption plus saving in a two-sector model. Right? Always true, by definition, in this two-sector economy. And in equilibrium, we know y equals to c plus I. Only in equilibrium, this is true. So what I can do in equilibrium, I can substitute c plus s with y. So I get c plus s equals to c plus I. This is still your equilibrium condition. I have just substituted the value of y, which is c plus s all the time. Isn't it? Every dollar has two uses in a two-sector economy. Either you consume or you save, you do both, right? So C cancels out, and you are left with savings equals to investment. And that's also your, gives you equilibrium, actually, right? Because you're deriving it from equilibrium condition. So let's use this approach next. We have the numbers. You have the savings function, right? And you also know investment. Let's plug those in and solve for y. So savings equals to minus 200 plus 0.25y equals to investment, which is 200. Okay. So this is your savings, and this is your investment. Right? So you are setting them equal, and then you have only one unknown, which is y. Solve for that. So you get 0.25y equals to 400. Negative 200 goes that side. And then you divide by 0.25y, you get the same answer, 1600. Okay. So it doesn't matter which approach you take, you will always get the same answer, as long as your calculations are correct. Sometimes we tend to make some silly mistakes somewhere, and then you'll get different answers. All right, any questions? Anything not clearly understood so far? Okay. So in that case, let's move on to multiplier. We'll discuss multiplier, and that would be chapter 8. Okay. So let's talk about the multiplier. So multiplier is basically the ratio of change in y, which is your aggregate output, divided by, or to the change in some exogenous variable you're looking at, like investment. Okay, so it's a ratio, change in y divided by, let's say, change in investment, and that's your multiplier. So change in y can be represented by delta y. Delta always refers to change here, and delta I refers to your change in investment. One of the exogenous variables we'll be considering. In this model, we have only one exogenous variable, which is investment. But later on, we'll have some more exogenous variables. For example, government spending in Chapter 9 will also be an exogenous variable. So this is basically your multiplier. Okay, so what does it mean? So multiplier allows you to answer a very important question, which is, let's suppose businesses invest $1 extra into the economy. Okay, by how much would GDP change as a result? Thus, that question you can answer by looking at multiplier, the value of multiplier. So if businesses invest $1 extra into the economy, right, by how much would GDP change as a result? Is that fine with everybody? What we mean by multiplier? Investment multiplier. So we call this investment multiplier. And later on, you will see a lot of other multipliers. For example, government spending multiplier, tax multiplier, balanced budget multiplier, open economy multiplier, money multiplier. A lot of multipliers you will learn about in this course. Okay, but for the time being, we're just concerned with this investment multiplier. Okay, and it tells you if firms invest $1 extra into the economy, by how much would GDP change as a result. That's your interpretation of multiplier. So the question that will come to your mind, let's first calculate investment multiplier. Let's use some numerical exercise. First, I'll derive multiplier for you, and then we'll do an exercise, and then we'll talk about interpretation of the multiplier. So let me derive investment multiplier. Actually, it comes from your equilibrium condition in the goods market. Okay. So let's go back to your equilibrium condition. So now we'll use notations instead of numbers. Okay. Generic form. So if you remember, consumption function is your A plus B times Y. A is your autonomous consumption, B is your marginal propensity to consume. And investment is given to you, is predetermined, exogenously determined variable. And we also know equilibrium condition in the goods market is given by this expression. Aggregate output equals to the planned aggregate expenditure. So let's substitute C and I in this equilibrium condition. So if I do that, I get Y equals to A plus B times Y plus investment, which is equal to I0. So I've just substituted the values of C and I in the equilibrium condition. So this is your C and this is your I. Keep in mind, I'm trying to derive the formula for multiplier. Okay. What is multiplier equal to? That's what I'm trying to answer. So next, like we did for algebraic approach, right? We have to solve for y. So let's do that. We have only one unknown. We know the value of A, B, and I0. Those values we know. The only thing that we don't know is y. Okay. So let's solve for y. What do I do to solve for y? Subtract what from both sides? by, isn't it? So 1y minus by equals to a plus I0. And then I factor out y on the left hand side, because y is common in both terms, right, on the left hand side. So if I factor out y, what do I get on the left hand side?
1 minus b.
That's correct, 1 minus b. And that equals to this expression, a plus I0. What do I next to solve for y? I want to solve for y, so what's the next step?
Divide by 1 minus b.
Divide by 1 minus b, both sides. That's correct. So you get 1 over 1 minus b times a plus I0. Right? That's your expression. If you divide both sides by 1 minus b, you'll get that expression.
Can you just put a plus I0 over 1 minus b?
Yeah, it's the same thing. Yep. Alright, so now we are ready to find the value of multiplier. So A is given to you, right? And investment is, predetermined variable. But now we are saying, let's suppose investment changes by $1 or by an amount delta, by some small amount delta, let's say, right? By how much would y change as a result? Can you tell me? So y does not change. Keep this constant. Sorry, A does not change. A is a given number to you, fixed number. The only thing you are changing is investment, I0, right? By an amount delta. Or let's say, just change it by $1. Forget about delta. Okay? So suppose you change investment by $1. This does not change. By how much would GDP, Y, change as a result? Anybody?
$1.
$1. So GDP will rise by $1 or some other value. Think about it. This number doesn't change, right? This changes by $1, increases by $1, I0. By how much would Y change as a result? It's not that difficult. So 1 over 1 minus b is multiplied by a. 1 over 1 minus b is multiplied by I0 as well, right? Forget about this term altogether right now. Just focus on this one. This changes by $1. By how much would Y change? $1 times
$1.
Times the bottom.
times the bottom. What is it?
1 minus b.
$1 times this whole expression, right? This thing. This is the coefficient of I0, right? This is also the coefficient of A, isn't it? Because you have factored it out. So, if investment increases by $1, GDP would rise by $1 times this expression, 1 over 1 minus b. Okay? Is that fine with everybody, or? Let me use simple numbers. Let's say I say, forget about it, y equals to 1 over 1 minus 0.75 times A is what? 200 plus investment, which is 200. Right? Instead of letters, let's use the numbers. Now I'm saying, forget about this expression altogether. That's fixed. Okay? That's your A. Now I'm asking you, this investment increases by $1. From $200, it becomes $201. Okay? By how much would GDP change if this does not change at all?
So it would be 1 divided by 0.75?
1 divided by 1 minus,
Oh, 0.25.
yeah, 1 minus 0.75, right? So 1 over 0.25. That's correct. And that's what you're trying to answer over there. It's the exact same thing. Okay. Does that make sense to everybody, what we're trying to do over there? Basically, this is, what we are doing is, it's simple calculus, basically. Right? You keep other variables constant, change one variable at a time, and see by how much the dependent variable is going to change, right? If you have just one variable, you're taking the derivative, right? Otherwise, if you have more than one variables, you are taking partial derivative. Don't worry about that. You don't have to worry about calculus in this class at all. Okay? But it's easier when you apply calculus. But that's what you were doing here. Okay? So what we just did here is, so change I0 by delta. Okay? And this remains constant. So basically you are finding delta y equals to 1 over 1 minus b times delta I. This thing, change in A is constant, so it's 0, right? So don't worry about it. So you're left with that. And then you can write that expression as delta y over delta I equals to 1 over 1 minus b. That's your investment multiplier. The formula for investment multiplier. So, don't worry about the derivations. Try to remember this. This is what you have to know. So, investment multiplier is this, 1 over 1 minus b. What is b in this expression?
So your starting investment? Or your slope, right?
Slope of
Consumption.
Function. What do you call it? MPC, marginal propensity to consume. So you can write investment multiplier, delta y over delta I, which is 1 over 1 minus B. You can write it at 1 over 1 minus MPC, marginal propensity to consume. Or even better, you can write 1 over what? MPS. That's good. So that's your investment multiplier, 1 over marginal propensity to save, or 1 over 1 minus marginal propensity to consume. Okay? So you should remember this formula for investment multiplier. Okay. So let's do, so we have the consumption function, previous example, right? What is the investment multiplier in that example? Can you tell me the value of it? The consumption function I gave you for the previous example. What is the multiplier? Let's just calculate that quickly. So tell me what is the investment multiplier? 4. So 1 over 1 minus 0.75, which is 1 over 0.25 equals to 4. That's correct. So investment multiplier in our example, the one we discussed previously, is 4. So this is a number you got. What does that mean? What is the interpretation of it? I defined investment multiplier for you at the beginning. What does this number mean then? Go ahead.
It's by how much the new investment changes the MPC.
MPC. Go ahead.
GPA.
GDP.
Or
Oh, GDP. Sorry.
GDP.
Yeah.
You're too concerned about your GPA, I guess. Yeah. But yeah, it's okay. GDP. That's correct. Yeah. So what it tells you, this number 4, is that if businesses invest $1 extra into the economy, the GDP would rise by $4. Okay? If businesses invest $1 extra into the economy, GDP would rise by $4. Or if businesses invest $100 billion, GDP would rise by $400 billion. Isn't it? That's your investment multiplier. Now, if you remember, we had the Great Recession recently, right? And how did we recover from that Great Recession? What did we do? Several things we did. We used fiscal and monetary policies to get out of the recession. Again, it's debatable which one worked, which didn't. But the economists are, they do agree about the effectiveness of fiscal and monetary policies to some extent, right? They have contributed in getting us out of the recession. So one of the things we did was a Recovery and Reinvestment Act that was passed by the Congress, and approved by President Obama. And it was, worth close to $800 billion, right? Approximately, let's say, $1 trillion. The recovery and reinvestment was basically, investing into the economy, fixing up, the roads and ports and bridges, building new schools, things like that, right? We invested a lot of money in infrastructure in the U.S. economy. That was your investment in the economy. That's what we mean by investment, right? Investment is purchase of plants, equipment, structures, and so on. So we invested almost $1 trillion into the economy. And because of that, GDP went up by more than $1 trillion for the US economy. Now, this number is too dramatic here. 4 is a big number. If you look at the US economy, the value of multiplier, again, it's not straightforward. There are a lot of things that go into multiplier formula itself, right? So we're looking at a very simple model here. But for the US economy, if you look at the multiplier, actual multiplier, it is close to 2, slightly less than 2%. Okay? So if you put in, if you invested $1 trillion into the economy, GDP would rise by close to $2 trillion. Okay? So So, one of the things we did to get out of recession was to invest heavily, and that did work to some extent. Even though it's not a recovery that we wanted, unemployment is still not at the normal levels, but slowly moving in the right direction. All right. So the question that will arise is, when you invest $1 extra into the economy, why GDP would rise by more than $1? If you remember the formula, the expenditure approach, right? Y equals to C plus I plus Z plus X minus M, right? So you increase, investment by $1, you would say GDP should rise by just $1, isn't it? According to that equation. But why is it rising by more than $1? What is happening? Go ahead.
Like the consumption function and those functions aren't straight lines.
Okay, so
Maybe curved.
okay. Consumption function is not a straight line. Anybody else? Any other ideas about it? Why GDP rises by more than $1 when we invest $1 into the economy? Let me give you a simple example to illustrate why GDP rises by more than $1. GDP is same thing as aggregate income, right? Or aggregate output, doesn't matter which one you look at. So let's focus on income aspect of it. Let's say a new plant comes to, a new business comes to Elmira. Just a small, simple example, let's take it. A new business, we open a new plant that manufactures, some, let's say, parts for, some helicopter or airplane, okay? A new business, and it hires 500 people locally. Invests, let's say, $50 million into the economy initially. The new business comes, they construct a new plant, they hire people, managers, workers, they buy raw materials locally and all those things, right? So let's say they invested $50 million this year. So GDP would rise by $50 million. We know that, right? Right away. The moment you pump in $50 million, GDP is going to rise by $50 million. But the question is, does it stop there? What will happen? So you start working for this company. You will draw a salary from this company. What will you do with your salary?
Does it like kickstarts more investment, more like?
That's correct.
Buying?
That's correct. So now, suppose somebody got hired by this company. They'll get a salary from this company. You'll buy a house, right? You'll buy a car locally. You'll buy groceries, clothing. You'll shop around, and that becomes income for somebody. Let's say you spend 80 cents of every dollar you earn, right? So your income went up by $1, GDP went up by $1, and you spent 80 cents out of it on other things, right? So somebody will earn that 80 cents in the economy. Somebody who sold you milk, somebody who sold you cars, somebody who sold you a house, and so on, right? And that becomes their income. Now, in the second round, GDP went up by 80 cents because somebody earned that in the economy. And then they will keep 80 cents of that because marginal propensity to consume is 80 cents. We're assuming it here, right? And they will also buy things. Somebody will go on a vacation trip or spend something on, right? And so 64 cents would be the income for somebody else. So there's a chain reaction that's going on. Can you see that? You started with a $50 million investment, and if you assume MPC is 0.8, right? So 80% of $50 million is $40 million, right? Next round of income that would be generated is $40 million. And after that, 80% of 40 is $32 million. Third round of income that would be generated is $32 million, and so on. Can you see? Go ahead.
Would it still rise if, like, because remember how we talked about the ones where if you're making a pizza and you buy the flour, and then you don't count the flour because they sold the pizza.
Intermediate good you're talking about?
Yeah.
Yeah.
If it's not for personal use, then do you not count it?
Right.
Okay.
What you're doing is, what we are looking at is, we're just looking at incomes generated,
Okay.
right? Or you can add up all the expenditure generated. So first round income is how much? First round expenditure is $50 million by the firm. They bought a lot of things to make this plant. Can you see that? And that $50 million goes into the economy, becomes somebody's income, right? Now, so income went up by $50 million, right? What do they do with this $50 million? They will spend 80 cents out of it for every dollar, right? $40 million would become income of somebody else in the economy, right? And they in turn would say, spend 80% of that. $32 million would be income in the third round. So basically, you're looking at a chain reaction started by this initial round of investment of $50 million. And therefore, GDP is going to rise. Okay? How much, by how much, is answered by this multiplier. Eventually, how much income would be generated? You can answer that question by this multiplier. Is that fine with everybody? What we mean by investment multiplier, how it works? All right, so that's your chapter 8, where we discuss how the value of real GDP or aggregate output or aggregate income, is determined in the goods and services market, where you have only two sectors. It's a very simple model, but allows you to understand how the value of real GDP is determined. Now, as I said, we are going to throw in more, complexities into our model. We'll add government sector, we'll add financial sector, foreign sector, and so on. Right? A lot of things will be thrown into this model and become more complex. We'll try to go closer to what the real world looks like. Okay, and answer this. Try to address the same questions and see what needs to change as a result. Okay. All right. So let's stop now and let's do some problems from your textbook. So you have textbook. Who has the 11th package? Chapter 8. Let's look at question number 6, 7, and 12. 6, 7, and 12. Let's work on those questions. Chapter 8.
I think we did 6 the last time.